Hello, juniors. Miss Elba here. Today I'm going to take you through 4 problems using law of sines, law of cosines, as we can apply those to word problems as a review for your upcoming exam. So let's jump right in. Let's look at the first one. For number 1, it says, during a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters and Peter skates for 7 meters. To the nearest tenth of a meter, how far apart are the skaters? Okay, so we have 2 skaters skating apart, right, from a point in which they were together. And we know that the angle between them is 15 degrees. And let's see, Peter skates 7 meters. Okay, so this is where Peter is. And on the other side is Jackie, and she skated for 5 meters, and they want to know, to the nearest tenth of a meter, how far apart are the skaters, right? So we need to know the length of the missing side. So I'm going to go ahead and just label the points. A is where Jackie is, B is where Peter is, and we'll call the point where they were together point C, and then we're looking for side length C. So we are given one angle measurement. We are looking for side length, and we're giving the other 2 side lengths. So because this problem only references one angle, we know that we're going to use law of cosines to solve for that missing side. So I'm going to write that at the top, but I want you to remember that for your exam, you will be given the formula for law of cosines and law of sines. Okay, so for this particular problem, we know that we're going to have c squared, that's the length we're trying to find, equals, I'm going to use the other 2 sides, which are 5 and 7, right? Those are my other 2 side lengths. So c squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of the angle opposite the side length I'm looking for, right? So we are looking for side length C. Opposite side is my 15 degrees for this angle here. So cosine of 15 degrees. All right, so we go ahead and start working this out. Remember, if you are comfortable using your calculator, a way to speed up these problems is to enter everything kind of in less steps, right? So I know I'm looking for C, but I have it set to C squared right now. So if I want C by itself, that means I'm going to enter this in the calculator as the square root of everything we just said. So 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15 degrees. And when you put this in the calculator, you should go ahead and try that now. If you have not, you should get C equals 2.5268, so on and so forth. And they're asking us to round in this problem to the nearest, let's see, tenth of a meter. So we know that C equals 2.5 meters. That is the distance between them. Okay, so that was a law of cosines problem looking for a side. Let's take a look at number 2. Number 2 is saying we have a bridge supported by triangular braces. If the sides of each brace have lengths of 63, 46, and 40 feet, find the measure of the angle opposite the 46-foot side. So we have a triangular base supporting a bridge, and each length of this base or brace is a different side or a different length. So we have 63 for one, 46 for another, and 40 for this one, we'll say. All right, and we are looking for the measure of the angle opposite the 46-foot side. So we're looking for this angle opposite 46. And they want us to round the nearest tenth of a degree. Okay, well, we look at this problem. We are given each side length, but we have no angles that we're starting with as given information, and we're looking for just one angle. So we know this references only one angle. So we are going to use law of cosines again. I'll go ahead and write that at the top. but this time we're using law of cosines to solve for an angle. All right. So when we have a problem like this, we want to remember that we need to set this up with the side length across from what we're referencing, right? So we're going to use the 46. So I'm going to go ahead and label the points of the triangle just because I do feel like that makes it a little easier to keep track. I'll call this point A, point B, point C. So in this case, then angle C is opposite of side length 46. So I will do 46 squared equals, I have my other two side lengths now that I need to enter. So 63 squared plus 40 squared minus 2 times 63 times 40 times the cosine of angle across, right from the 46, which is cosine of C. All right, so that's all set up. I can go ahead and start plugging some of this into my calculator. I do my 46 squared, and I get 2116 equals 63 squared is 3969 plus 40 squared is 1600 minus the 2 times 63 times 40 in your calculator, which give you 5040 cosine of C. All right, so I can move the 3,969 to the other side. So I'm going to subtract that from both sides. And that gives me negative 3453 equals negative 5040 cosine C. Remember, we cannot combine the 5040 with the other numbers out front, right? Because 5040 is connected by multiplication to cosine C. So to move that negative 5040, we have to then divide to get that to the other side. So I'm going to divide both sides by 5040. And that would give me cosine C alone. So cosine C equals negative 3453 over negative 5040. Okay, and then to find C, because right now we have cosine of C, we can use arc cosine and plug that into our calculator. It's always the cosine with the superscript of negative 1, right, is arc cosine. And then we would plug in what we have, negative 3453 over negative 5040. And we should find, let's see, it should come out to about 46.755. I think it keeps going. And they want us to round to the nearest tenth of a degree. So I can say that angle, which we labeled C, right, that missing angle across from 46 equals 46.8 degrees, rounding to the nearest tenth of a degree. So this one was law of cosines, but we used law of cosines to find an angle this time, versus in problem 1, we used it to find a side length. Let's look at problem 3. It says, two observers are standing on a shore a half mile apart at points A and B and measure the angle to sailboat at point C at the same time. So we have two observers standing on the shore, and they're both trying to measure their distance to a sailboat. Okay, we know they're standing a half mile apart. It says angle A is at 63 degrees, angle B is at 56 degrees, and they want us to find the distance from the observer at point B to the sailboat to the nearest foot. Okay, so standing on the shore, I have observer at point A and I have an observer at point B. And off in the distance, they are both looking at a sailboat somewhere out here. We'll call that C. Let's see here. You know what I'm going to erase that. And I'm going to see here. I'm going to draw this in first. So this is the distance between A and B. They gave as 1/2 mile, and we got a hint of how big a mile is. So if I'm going to take 1 mile divided by 2, right, because they are a half mile apart, 5280 divided by 2 equals, what do we get? They are 2,640 feet apart. So this is 2640. Now I know angle A is 63 degrees and angle B is 56. So I'm going to go ahead and put point C out here. That's to the boat. So this one was 56 at B. And this was 63 degrees at A. Okay. Let's see. So we're looking for a distance. We're looking for the distance from observer B to the boat. So I want to go ahead and switch colors here for a moment. If I'm looking for this distance here on this side, right, from point B, observer B, out to the sailboat, what side length is this really? This is actually side length A, right? Because side length A is the side opposite of angle A. So they're asking us to find the length of side A. So we look and we see what do we have? What are we starting with here? We've got 2 angles already given. We are looking for a side length, but because it references 2 angles already, I know I can use law of sines. So I'm going to just jot that down for myself, that I'm using law of sines. When I look at the information given in the problem, I can see right away I've got 2 angles, but just 1 side length given. However, I know something else about this problem, right? At angle C, right by the boat, I can solve for that angle because I know the other 2. So for any triangle, right, 180 minus, in this case, 63 minus 56 gives me the third angle in the triangle, which comes out to be 61 degrees. So I know all 3 angles now within my triangle. Let me clean this up a little bit. It didn't quite work out how I wanted it to. There we go. 61 degrees. That looks a little better. Okay. So now I can go ahead and use law of sines to solve for that side length. So I know side length A is what I'm looking for over the sine of A, which is the sine of 63, is equal to side length C, which is given as 2640. That's my half a mile, over sine of angle C, which is 61. And then we can go ahead and just cross multiply and see what happens. So we go ahead and do that. So we have A sine 61 A sine of 61 degrees equals 2640 sine of 63 degrees. Now if I'm looking to get A by itself, I can then divide both sides by sine of 61. And I find out that A, in my calculator, if you tried this out, should give you 2689.462 and so on. And they wanted me to round to the nearest, let's see, nearest foot. So A is about 2,689 feet. So this was an example of using law of sines to solve for a side length. Now we have one further example here. So this time, let's take a look at our problem. The plane flies 500 kilometers with a bearing of 44 degrees west of north from Naples to Elgin. The plane then flies 720 kilometers from Elgin to Canton. Find the angle of the route as the plane changes course in Canton. rounding to the nearest degree. Okay, so they show we have a little diagram for this one, and they show the starting point of the plane, and we know the plane flies 44 degrees west of north. So if we look, let me just get the highlighter here. If this is north here, right, they're saying 44 degrees west of north creates this angle. However, that angle is not exactly in our triangle, is it? It's outside of the triangle. But if we look, we can figure this out fairly easily because we know that this is the 90-degree angle here. So 90 minus 44, we find out that this angle then is 46 degrees. So we have that piece of information for our triangle right at the start. But what we're actually looking for is the angle as the plane changes course in Canton. So we're looking for this angle over on this side. So let's take a look. Okay, so we have two side lengths. We have the 500 and the 720. And we are looking for an angle. We are already given one angle, and we're referencing a second angle. So we know this problem in total references two angles. So we're going to use law of sines to set this one up. So let's see what we want to do here. We are going to see what we have and what we can use. Well, I know a side length of 720 across from an angle 46. And I do know a side length of 500 would be across from the angle I want. So we're always going to make sure these line up properly. And then we can go ahead and set this up. So I have 500 over sine of my missing angle. This is Canton, so let's make this one, we'll call it C, sine of C. Okay. For keeping everything straight, I'm just going to go ahead and label the other points. This will be B. This will be A, where the plane started. Okay. So 500 over sine of C equals 720 over sine of 46 degrees. From here, once you have your law of sine set up, go ahead and cross multiply. Gives us 500 sine of 46 degrees equals 720 sine C. Okay, well, if I want to get sine of C by itself, I can divide both sides by 720. And you can go ahead and enter this in the calculator. So we know that sine of C, right? We're still looking at sine of C. So you could do this all in one step if you want to get to C. We can do C is we can use arc sine. So sine with the little superscript -1, right? Arc sine, and then we can plug in everything we have. So it's 500 sine of 46 degrees over 720. And you should come up with C equals 29.9696. It keeps going. And they wanted us to round to the nearest degree. So C equals 30 degrees. And you look back in your problem. Yeah, that looks like a reasonable number. So 30 degrees was the missing angle. Let me clean that up a little bit. There we go. 30 degrees was this missing angle over here by C. All right, so now we've seen 4 problems in total, 2 for law of sines, 1 finding an angle, 1 finding a side, and 2 for law of cosines, 1 finding an angle, 1 finding a missing side length. So I hope this helps as you review. The assignment for today is going to be problems just like this for you to get your feet wet, trying to make sure we understand all of this. Please reach out if you have any questions, and good luck studying.